welcome to page 48 in your workbook, lesson 13, which is currency conversions and the constant proportionality. Our first problem is just to determine the value of euros given the value of US dollars. Now we have an exchange rate up there, and it says the exchange rate of US dollars to euros in 2008 was about 5 to 4. That means it took 5 US dollars to purchase 4 euros. So I'm going to set up a proportion and determine the cost of euros. Now these are pretty simple, but there's a deeper level going on here that we'll try to explain. But the first problem is we have 10 US dollars and we want to turn them into euros. This problem is set up. I just want to reinforce here that we're at US dollars to euros. When it says that, then it says 5 to 4. The 5 goes with the US dollars and the 4 goes with the euros. So I set it up in fraction form here, and I put in the units. Dollars to euros equals dollars to euros. So this one's pretty simple from basic fractions. I can just do this. And so I get $10 is 8 euros. And that's all there is to that one. So our second problem is to convert $25 into euros. So I set up a proportion with my original knowledge. $5 is to 4 euros, and then when I have $25 is to I don't know how many euros. I can, of course, do this by just multiplying the top by 5 and the bottom by 5. Hope you can see that. And if we do that, the answer is going to be 20 euros equals 25 US dollars. But let's do this a little slower using cross multiplication, because it's not always so neat. This could be $28, and then what would you multiply 5 by to get 28? So our fundamental technique of cross multiply and divide, I'm going to use that. And I'm going to kind of like keep this all together. So I'm going to get $5 times euros equals 4 euros times $25. And notice the 25 is what we're trying to convert into euros. So now I'm going to divide by $5 and divide by $5. And so I get euros equals 4 euros over $5 times $25. Which, of course, if you work it out, you're going to get that 25 divided by 5 is 5. 5 times 4 is 20. So 20 euros is the same as $25. But notice what I have here. That's the result of my cross multiplying and dividing and working it through. I basically have euros equals 4/5 times the number of dollars that I was trying to convert. So it's a little confusing, don't worry about it. We'll go over it again. Okay, so this is the conversion number 3, converting $35 into euros. And I'm going to use the information I gather here to do this problem, converting $55 into euros, in a more quick manner, and then I'll show you why that's important. So I'm going to do cross multiply and divide again. Of course, I could do 7 over 7 and do it that way, but I'm trying to develop something here. So we're going to cross multiply, so I get $5 times euros equals 4 euros times That's euros times $35. I don't know where my euro went. There it is. Okay, so I'm going to divide both sides by $5. And these cancel, of course. So I get euros equals 4/5 times the $35 that I'm trying to convert. So we can simply do this. 35 divided by 5 is 7. 7 times 4 is 28. So the answer is 28 euros, which isn't really that important, but that's what it is. So let's do this one. Let's look at this one. It's the last one. Convert $55 into euros. So I'm just going to go down here and say, well, my euros is going to equal 4 euros over $5 times $55. This is the constant of proportionality. It's a result of cross multiplying and dividing. Notice also how these units work. This is euros over dollars times dollars. So the dollars are going to cancel just like a fraction, and I'm left with euros. So 55 divided by 5 is 11. 11 times 4 is 44. So $55 equals 44 euros. Now I'll show you why this is convenient to know this, which is also called K, the constant of proportionality. Most countries have their own currency, but the euro is a shared currency among many European countries. You can't just walk into a French cafe and pay with US dollars. So there's a lot of exchanging of money with different countries going on every day in the world. Exchanges, therefore, are going on all the time. So to come up with a quicker way, and here's an Excel file, which we're going to convert US dollars into euros. To come up with a quicker way, we're going to use that idea of K. So let's look at a US dollar, 714 US dollars, which is right here. And let's convert that into euros and use that idea to quickly do this simple spreadsheet. So the first situation in the Excel spreadsheet was to convert $713 into euros. And then they wanted to convert $139 and $699 into euros, etc. So you want to come up with a quick way of doing this. So I'm going to cross multiply, and I get $5 times euros equals 4 euros times $713. Now realize that this 713 is going to change to 139, 699, etc. So if I divide both sides by $5, whatever this is, the dollars cancel, and I get 4/5 times the amount of dollars that I want is euros. So the equation that I'm going to use is euros is going to equal 4/5 times the amount of dollars I'm converting. So let's move over and do that in Excel. Okay, from the worksheet we just did, we kind of have an equation. We know that euros equals 4 divided by 5 times the number of dollars that we're trying to convert. And so coming over here in this cell, we can say we want to convert $714 into euros. We're going to use the constant of proportionality, which we discovered by cross multiplying and dividing. So we have euros equals, and we can use these up here, 4 lock divided by, 4 lock divided by 5 lock times that amount of dollars, 714. And I changed the insignia to euros here, which you can do up top. Now I can just drag it down. And so this is how it's going to work. You're not going to sit there and cross multiply and divide every time you might make a conversion. That's why this basic formula y equals kx, where k is the constant of proportionality, can be useful. So we'll do A here. Is there a shortcut for converting dollars to euros? And the answer is yes, we just went through it, right? So how are we going to convert $100 to euros? Well, we have a basic equation. Euros equals 4/5 times dollars. If we know the dollars, euros equals 4/5 times 100, which would mean 100 divided by 5 is 20, and 20 times 4 is 80, or do it on your calculator. $100 is worth 80 euros. What that means is that this conversion, just to be clear about this, what that conversion means is that $5 has the same buying power as 4 euros, supposedly. So which is worth more, $5 or 5 euros? Well, $5 has the same buying power as 4 euros. So $5 is going to have less buying power than 5 euros. So the 5 euros is worth more. And finally on this one, what's worth more? $20 or 19 euros? That's actually a pretty good question. There's a lot of ways to do it, but I'm going to do it this way. I have this basic equation, so I'm going to figure out what $20 is worth. $20 divided by 5 is 4. 4 times 4 is 16. So $20 is worth 16 euros. So what's worth more? 16 euros or 19 euros? And the answer is 19 euros. So in problem 2 here, we want to determine the cost in rubles for the below items. And it gives us the cost in dollars. So this sort of reinforces the idea too that purchasing power, $10 has the same purchasing power for a movie as how many rubles, which is the Russian currency. And here's the exchange rate. Notice it says US dollars to Russian rubles, 3 to 235. So I'm going to take that currency exchange, 3 to 235, and convert $10, which it costs for an average movie, into how much the average movie would cost in rubles. And why I do that, I'm going to find the equation so I don't have to constantly repeat cross-multiplying and dividing. So I've set up my ratio here, which is $3 to 235 rubles. There's my relationship, and I am going to convert $10 into I don't know how many rubles. So how do you solve a proportion? Cross multiply and divide. But I'm going to do this such that I don't have to keep doing this cross multiply and divide over here, because they're the next ones I have to do. So I get 3R equals 235 times, at this point, $10. But this one's going to change all the time, right? Because I got all these other ones to do. So it's the same process with this changing. Divide by 3, divide by 3. And I get R equals, multiply 235 times 10 divided by 3 in our calculator. and I get 783.33. Now I'm going to basically redo this process, but I'm going to do it in a way which gives you the ability to create these equations on your own. So if you follow the logic here, you'll be able to do this. So here's my basic relationship. $3 is to 235 rubles. And I want to create an equation where this keeps changing, the dollars keep changing. So I'm just going to use D for whatever the dollar amount is I want to convert, and R for the rubles. So I'm going to cross multiply, and I get 3R equals 235 times D. Divide both sides by 3, and I get R equals 235 divided by 3 times D. Follow that logic? It's just simply using variables here instead of actual amounts like this or these. So now I'm going to actually go on my calculator and divide 235 divided by 3. And I get 78.33 times dollars, which is the way in which now I can use this equation to convert these dollar amounts into rubles. If I wanted to flip it, right, here's my cross multiplication, right? 3 times R equals 235 times D. If I divided both sides by 235, I would get dollars equals 3 divided by 235 times rubles. And I could use this equation to convert rubles into dollars. So you have both equations. There's a couple more subtleties in here which we'll wait on. So here's the equation that we developed. So now I'm just going to take my dollar amount and put them into my equation. So rubles equals 78.33 times, in this case, 55. And I'm simply going to put it in my calculator. And I get 4308.15. Now I'm going to change it $850 into rubles. So I'm just going to put 850 here and go on my calculator again and multiply 78.33 times 850. And then after I do that, I'll put the answers down. I'm going to change that into 6,500 and get 78.33 times 6,500 and put the answer here. So why don't I put the answers in there? So there are the answers. So is there a shortcut for converting US dollars into rubles? Yes, and we developed it right here. That's the shortcut. It's an equation of the form y equals kx, and k is 78.33. So I'm going to go rubles equals 78.33 times 100. Multiplying by 100, you move the decimal 2 places, and you get 7833. 7,833 rubles is the same as $100. What's worth more, $5 or 5 rubles? you put it on pause and think about these two because these are good questions. Well, we know that $2, we know that $3 is equal to 235 rubles. So obviously, $5 is worth a whole lot more than 5 rubles. Which is worth more, $20 or 1250 rubles? Well, we can go up here and look what we had. We had $10 is worth that many rubles. If I doubled this, I'm going to get over 1,500. And so this $20 is worth more than that amount of rubles. So here's question 3. Your friend comes over and offers you either 1,000 Mexican pesos or 25 American dollars. Which one would you take and why? And there's the exchange rate, which I put over here as a written in fraction form. So, I don't know, put it on pause and think about this. What would you do? Well, I am going to just simply say, okay, I want to know, here's 1,000 pesos. So I want to find out how many dollars that's worth. And if that's worth more than $25, I'm going to take the pesos. Now you can also do it this way. You can say, okay, how many pesos is $25 worth? And if $25 is worth more than 1,000 pesos, I'm going to take it. If it's worth less than 1,000 pesos, I'll take the 1,000 pesos. That's kind of the way I would look at it. There's a lot of ways to look at it. So I'm just going to cross multiply. I'm not going to bother setting up an equation because it's only one conversion. And I'm getting 625. So that means $25 is the same buying power as 625 pesos. Then obviously 1,000 pesos is worth more than $25. So I'm going to take the 1,000 pesos. This is a good reasoning problem. You got to think through it. So we're going to deal more now with the constant of proportionality. You can write an equation of the form the output equals k, the constant of proportionality, times the input if you have two things that are proportional. Now, it's usually pretty easy to figure out if they're proportional. So, but let's do a couple examples off the book here, just so you got the idea, just so you understand what proportionality is. If two things are proportional, then you can write an equation of the form y equals kx. So this is the one we just did. Dollars to euros. $5 is the same as 4 euros. Now the rule of thumb is if you double one, what happens to the other one? And if it doubles, which in this case it does, then this is a proportional relationship. So therefore you can take this relationship or this relationship, because they're the same, right? 5 over 4 is the same as 10 over 8, and create an equation of the form y equals kx, which we did, right? In fact, if you keep going, every relationship here, whoops, I need that in white, every relationship is going to be proportional to the other relationship. $20 is 16 euros. I can cut 5 in half and go $2.50 is the same as 2 euros, right? Notice every solution is going to be the same. They're all equal. It's like a ruler, right? A half an inch is the same as 2/4 of an inch, is the same as 3/6 of an inch, is the same as 8/16 of an inch, etc. So in a proportional relationship, all the solutions to the equation y equals kx are equivalent. But the rule of thumb is if you double one quantity, like 5 to 10, you double the other. That makes it proportional. Let's look at another one. So here's one. Water weighs 8.35 pounds per 1 gallon. So if I double the first quantity, which would make it 16.7 pounds, can I double the second quantity and make that 2 gallons? And the answer is yes. So the relationship pounds to gallons, you can form an equation of the form y equals kx. Okay, let's look at one more here. So our final one is radius of a circle, which is, as you recall, it's like that, to the area. And the area of this circle with the radius of 2 inches is 12.57 inches. So if I double the radius, will I double the area? In other words, so I get a bigger circle and I have 4 inches. Is that true? So is this going to be 25.14 inches? Square inches, because it's area, right? Radius of a circle to its area. Are they proportional? Do they form a proportion? Well, think about it, right? When I double the radius, do I double the area? So I pulled this little Excel file up, put in radiuses and inches, and the area will then be in square inches. And here's the formula for the area of a circle. And I'm just going to go ahead and find the area based on the radius, and then see if the radius doubles, does the area double? And that would make it proportional. So this is equals pi. Pi is a function here, and that's how you put pi in, times the radius raised to the second power. And I put it at 2 decimals. And so I'll just drag this down. And so we're trying to answer the question, is this a proportional relationship? Inches to area of a circle. So if I take 1 inch and double it, do I double the area? And the answer is no. If I go from 3 inches, which is 28, to 6 inches, do I get like 57? No. No. In fact, when you double the radius, you quadruple the area, which is a completely different kind of relationship and cannot be written in the form y equals kx. In fact, it's written over here in the form y equals pi times the radius squared. This one is done for you in the book, but I just want to go over it a little bit. So it says gold weighs 48.25 grams for 2.5 cubic centimeters. So a cubic centimeter is volume. I'm just going to put a picture up here of what a cubic centimeter is, what it looks like, and that would be right here. And it would be something like that. It's like a box that's 2.5 centimeters in length, width, and height. So if you fill that up with gold, it's going to weigh 48.25 grams. And that's a cubic centimeter, 2.5. So the question you got to ask yourself, if you double the size of this box, will you double the weight of the gold that you put into the box? And the answer should be yes, because if you double the volume of gold, you'll double the weight of gold. So we're going to set up a proportion, and we're going to do it in the kind of way we did it before, right? Grams to cubic centimeters, grams to cubic centimeters. We're going to name the variables weight and volume. Weight for grams, volume for cubic centimeters. Cross multiply, and then once you cross multiply, you can either solve it for the weight or solve it for the volume. So here they solved it for the weight, and they got 28.25 over 2.5. When they divided that, you get 19.3. So 19.3 is K. Over here, notice that it's not 48.25 over 2.5, it's 2.5 over 48.25. And when you divide that, you get 0.0518. And so there's the equations. The units of K are different, they're flipped. And we're going to deal with that. Note that 19.3 and 0.0518 are what? Think about that. And if you answered reciprocals, you would be correct. Let's just take a quick look at that. So we're just going to define reciprocal here. So if you have a number, the number that you multiply it by is the reciprocal if the product is 1. Okay? And I'll put a definition down here. So I'm going to multiply 2/3 by a number so that the product will be 1. Product meaning the answer, right? So hopefully you see that that's just going to be 3 over 2. Multiplying straight across, I get 6 over 6. The reciprocal of 3/4 is 4/3. You multiply them straight across, you get 1. The reciprocal of 5 is 1 over 5. The reciprocal of x is 1 over x, provided x does not equal 0. 0 is the only number that does not have a reciprocal. And this, I get 1. Now think about this one. 1.34 times what number is 1? How about 1 over 1.34? So we've dealt with reciprocals in the last several problems. I'll just run them up there. So here's the equations that we've been working with lately. Like for instance, this one, euros equals 4/5 times dollars. And dollars equals 5/4 times euros. Notice that 4/5 and 5/4 are reciprocals right there. Now I'm going to change 4/5 into a decimal, 0.8. I'm going to change 5/4 into a decimal notation, 1.25. So if I multiply 0.8 and 1.25, what do I get? And hopefully you would say you get 1, because 0.8 is the same thing as 4/5 and 1.25 is the same thing as 5/4. This is usually how we write K in the equation y equals kx. So here is rubles. Rubles equals 235 divided by 3 times dollars. Dividing this, we get that. So they're the same number. Taking the multiplicative inverse, the reciprocal, and reversing the equation, you get dollars equals 3 over 235 times R. Divide this, and you get this. So the question becomes, what is 78.33 times 0.01277? And hopefully you'll say, well, that's 1, which it is. And the last one here that we did, we had an example on with gold. We got this equation, W equals that, and dividing this, we get the way we normally write K as 19.3, because when you divide it, that is 19.3, and reversing it, you get that. So now I'm going to ask a little different question. What is 1 divided by 19.3? So here's 19.3. And I want to know what 1 divided by 19.3 is without a calculator. And if you answered that it is this, you are correct. So this just shows you how the reciprocal works in these equations, y equals kx. Next, we're going to look at the units, which are really important. So we're going to look at a simple y equals kx formula. Your salary is equal to $13 times the number of hours that you work. Here's a table of values. We're going to fill it in. But the question is, like for 5 here, how do you input 5 hours and miraculously come up with, that would be $65? In other words, how do you transform hours into dollars? By what miracle can that happen? And the key is right here. Because while we are writing that as $13, it is actually $13 per 1 hour. And so when I multiply it by 5 hours, the hours cancel, and I'm left with $65 for my output. And that's the key to K. K is a ratio, and the ratio has units associated with it so that the equation will work properly. So if I put 10 hours in, I'm just swapping this for 10. The hours still cancel and I get $130. And if I put 20 in, again, the hours just cancel and I get $260. This comes from fractions, and I'm just going to do one fraction to show you. So let's go 5 over 16 times 16. So the units are behaving, the units, hours and dollars, are behaving in the same way that this would behave. Hopefully you know the answer to this is just simply 5 because the 16s cancel. Okay, so we're going to deal with the units of K in these equations. So hopefully you know that this here is K, 4/5. Now we would normally write it in an equation as 0.8. But let's leave it as 4/5. What I want to know are the units here. And the key to that is saying, oh, well, I know this is dollars and this is euros. So if I'm inputting dollars, how does dollars miraculously become euros? And the answer would be because euros would be in the numerator of K and dollars would be in the denominator. And that way, when I multiply by whatever amount of dollars, the dollars would cancel, and I'm left with the number of euros. So this one is different, right? I have 5/4, that's K. Or we could write it as 1.25 over 1. And I have euros here. And I want to input euros and output dollars. So the euros have to disappear. How do I make euros disappear? By putting them in the denominator. And then that obviously has to be dollars because that's going to be my output. So the euros would cancel and I get dollars. So there is the units of K in this equation. Now here, we got to find the units of K in this equation. Rubles equals that times dollars. Well, first thing to recognize is that K is always a ratio. So if you don't see a number there, that's going to be 1. The dollars have to cancel, so the dollars will be on the bottom. And the rubles, that's what we're changing them into, that would be in the numerator. So the units of K would be rubles per dollar. So this means there's 78.3 rubles for every $1. Now this is the opposite. Again, that's over 1. Well, if I'm inputting rubles and outputting dollars, I have to change rubles into dollars. So I have to get the rubles eliminated and the dollars appear. So the units of this K would be dollars over rubles. So for the next problems, 2, 3, 4, and 5, the first thing we have to decide, are they proportional? Is the relationship proportional? Because if it's not, you can't make equations. Well, you can, but they don't mean anything. So 2 says murders, 756 in Chicago in 2016, and a population of 2,716,000. Is it proportional? Well, if you double the people in Chicago, would the murders automatically double? The answer is no. Who knows what's going to happen? So that's an easy one. It's just simply no. Okay, for 3, pesos, 160 pesos to 8 US dollars. Is it proportional? And the answer is, well, if I double my pesos, would I double my dollars? And the answer is yes. This is a proportional relationship. So can I make 2 equations? The answer is yes, and let's make them. So start with either 8 over 160 or 160 over 8. So I'll start with 160 over 8, pesos to dollars. And I'm going to use P for pesos and D for dollars. So that's how you set it up when you want to find an equation that'll work, right? I'm not trying to find a solution. I'm trying to find an equation. So this is 160 times D equals 8 times P. Now I can go either way. I can find D equals, or I can find P equals. So we'll do both. Let's divide by 160, both sides. That cancels, and I get D equals 8 over 160 times P. And I'm going to divide this on my calculator. So I'm going to get D equals 0.05 times P. So this means if I put in the number of pesos I want, I can convert pesos to dollars by multiplying by K, which is 0.05. Now, if you recall from our previous discussions, this is just going to be 160 over 8 times D. So I would use this if I wanted to find pesos given the input of dollars. And I put that in my calculator, and I get 20 times dollars. So now, the constants. There is the constant here. And there is the constant there. So the constants are 0.05 and 20. Now what are the units? Well, let's look at the units of 0.05. First of all, it's 0.05 over 1. And I'm multiplying it by pesos. So the units are going to be pesos on the bottom and dollars on the top. So for this 0.05, the units are dollars over pesos. And for this one, this is 20 over 1. I'm multiplying by dollars. So it's going to be dollars on the bottom and pesos on the top. So they are the units, pesos per dollar. In other words, you can read it 20 pesos per $1. This one you could read 0.05 pesos per 0.05 dollars per 1 peso. So here we're going to look at Canadian dollars to US dollars. First of all, is it proportional? And hopefully you would know yes. If you doubled the amount of Canadian dollars, you would double the amount of US dollars. Now for the equation, I'm going to use C for Canadian dollars and D for US dollars. You can use anything you want. So I have my initial ratio, I'll do it this way, 15 Canadian dollars to 11 US dollars is going to equal, I don't know how many Canadian dollars to I don't know how many US dollars. Remember, I'm not trying to solve anything. I'm just forming equations. So we cross multiply, and I get 15 times D equals 11 times Canadian. Now I can solve either way. Let's solve for C. Divide by 11. Divide by 11. These cancel, and I'm left with C equals 15 over 11 times D. Now hopefully you can follow that. So D is going to equal, stop, pause, let me know. I'm going to write it down. 11 over 15 times C. Now what you can do, if you don't see this, you can always just stick with the cross multiplication product. And divide both sides by 15. And you'll get that. But these are reciprocals, or multiplicative inverses. So now I'm gonna leave this one alone. Here's K. And being that we're inputting Canadian dollars, I have to have this as US dollars over Canadian dollars. So there's the units of K in this equation. Dollars over Canadian dollars times Canadian dollars, and they will cancel. Now let's take this one and divide 15 divided by 11. And I get about 1.36. So there's K there. So we got the two K's that you can put down. You got the units for that one. And I'm going to find the units for this one. Well, recognize that I'm multiplying by dollars. recognize also it's a ratio. So if I'm multiplying by dollars, I'm going to have to eliminate the dollars so that I get Canadian dollars. So the units for this 1.36 would be Canadian dollars over US dollars. Okay, so number 5, we got temperature conversion. Celsius to Fahrenheit, and we have the inputs and the outputs, some of them given to us. First question you want to answer, is it proportional? And the answer is no, it is not proportional. And there's two ways to tell. One, hey, if you double Celsius from 5 to 10, does Fahrenheit double from 41 to 82? And the answer is no. So that's one way to tell. Another way to tell is right here. If the input is 0 on an equation y equals kx, I want you to think about this. If the input is 0, the output is 0, right? Because any number times 0 is 0. So one of the solutions to a y equals kx formula is 0, 0. And here we have 0, 32. So that's the other reason it cannot be a proportional relationship. And I want you to think about why this is. I mean, I could show you algebraically why it is, but think about it this way. If you have 0 US dollars and you want to trade them in for rubles, how many rubles do you think you're going to get? And the answer is 0. If you have 0 gallons of water, how much do you think it weighs? And if you guess 0 pounds, you're correct. If you have 0 pesos and you go to the bank and say, can I trade these 0 pesos in for US dollars? You're going to get 0 US dollars. So a hallmark of y equals kx equations is that they contain the solution 0, 0. This doesn't. So I switched over to hovercraft here for our last problem in lesson 13. Number 6. It says your neighbor Julie works at a local township hall in Van Buren County. One day at lunch, she was telling me that many residents would come to the township hall and either ask what their house was appraised at, in other words, how much it was worth, at a given tax bill, or what their tax bill should be given the appraised value of their home. Julie said a house worth $125,000 has an annual tax bill of $1,850. She then explained that just this morning the resident came in with an appraisal on their house of $225,000 and asked what their taxes would be. Julie showed you on a napkin how she calculated this. So it's a proportional relationship. If you double the value of a home, you're going to double the taxes. So she set up a proportion, and how do you think she got that? And the answer is she cross-multiplied and divided. And I'm going to ask you one other question. I'm going to write this in here. If I take 125 and divide it by 1850, and then I'm going to take 225,000 and divide it by 3,300. And what do you think I'm going to get? Well, I don't know what I'm going to get exactly, but I'm going to tell you right now what will be true. Let me put that up there. And there it is. 125 divided by 18, it's the same number. Of course it's the same number because all these relationships in proportions, all these ratios are the same. Due to your knowledge of QR and Excel, you brought her the following spreadsheet the following week and explained how this could make her job much easier. So let's look at the spreadsheet, which is right here. There's the known value that she was using, property value of taxes. This one she set up where you input the property value and output the taxes. And this one she set up where you input the taxes and you can output the appraised property value. All right, T is taxes and V is property value. So let's look at some of these equations here. Okay, so we're going to look at the equation for this one here. Input value, output taxes. So that would be T equals, because it's always the output equals. Now these are of the form y equals kx. Well, y is just the output, so that's T. So I have T equals k times value, because the value is the input. I just need to find k. Well, I want you to think from before. I'm not going to do much math here. From before, what are the units of k? Well, I'm going to input value and output taxes. So k has got to be equal to taxes over value. That's the units, because the values got to cancel and I got to get taxes equal taxes. I want you to think about that. Then it's pretty simple to put the numbers in. So the formula is going to simply be equals, which means taxes equal. It's going to be I3 divided by I2, taxes divided by value. There's K, taxes divided by value, times this cell here, which is A6. So I want you to think from before. Now we're going to flip it, right? Which means we're going to input taxes and output value. So I want V equals, the output equals. I'm going to make this pretty simple. V is going to equal the inverse of K in my other equation, or the reciprocal, which is going to be value over taxes times taxes. So for my Excel formula, I'm going to start it out right here. Only I'm going to flip this because I'm using reciprocal. So it's $I, $2 divided by $I, $3 times, put that down there a little bit, right? It's the inverse of this, times, I'm going to put it in this cell, times that, which is D6.